Hi, my name is Manish Gupta, and in this video, I'm going to talk about OpenAssistant Conversations. Let's get started. Right. So, in general, why is human curated conversational data required? And what is OpenAssistant? So, OpenAssistant is basically a conversations dataset, and it is also a bunch of models which are fine-tuned using this dataset, right? So, it's the name of both of those dataset as well as models built using this dataset. And in general, why do we need such a data set? Well, because instruction fine-tuning using recipes like Instruct GPT requires such data, right? So Instruct GPT made this three-stage procedure very popular to align language models. In the first stage, people do supervised fine-tuning. Second stage, build reward models, and in the third stage, they actually train the model further using reinforcement learning with an algorithm called PPO. In the supervised fine-tune stage, these human-generated demonstration examples of desired behavior are used to do supervised fine-tuning, right? In the second stage, a reward model is trained on human annotated rankings for different model outputs. And in the third stage, this reward using the reward model as the reward function and the fine-tuned supervised fine-tuning supervised fine-tuned model, you do further training to maximize the reward generated by its responses using PPO methodology. Okay. So as you noticed in both of these things, you require human-generated demonstrations or human-generated rankings, and that is why you need a large-scale data set. Now, in general, these data sets have been proprietary, right? Therefore, there was a need to build a large open data set, which is where OpenAssistant it started this initiative of creating a large data set. Now, once they essentially collected that data set and trained OpenAssistant models, they trained OpenAssistant models on top of Pythia 12 billion. And then they did user preference study to find how good these models are. With around 6,000 samples, they observed that these OpenAssistant models, Pythia 12 billion, actually had a win rate of 48.3 against GPT 3.5 turbo model. So which basically means that the answers generated by Pythia 12 billion are 93.5% as preferable as those generated by the GPT 3.5 turbo model. Here is an example of a prompt, why some people prefer short happiness, and here is an example of an answer by OpenAssistant versus GPT 3.5. So of course, what you observe straight off is that yes, the answer is pretty long and elaborate in nature, but if you read it more carefully, you would also observe that it covers multiple opinions and point of views compared to pretty short and sort of a very small focused answer by GPT 3.5. So what are the characteristics of OpenAssistant Conversations dataset? How was it collected and gathered, right? So the OpenAssistant Conversations dataset contains conversation trees. Then the conversation tree at the top, at the root node, is a prompt, which basically initiates a conversation. And then there are two kinds of responses, assistant responses or prompter responses. Now, every assistant response can have multiple prompter responses. Similarly, every prompter response can have multiple assistant responses, right? Each of these responses also contains some metadata, which I'll talk about here. So these are labels provided by humans. Right? So the entire tree is created by human labeling, or other many such trees are created using human labeling. Just to give an idea, the entire data set contains about 161,000 messages with 66,500 conversation trees across 35 languages, annotated with about 461,000 quality ratings, right? So let's talk about what are these quality ratings, and then we'll come back to the stats. So while creating this data set, there were four main kinds of tasks which were identified to be done so as to build these trees. First task is creating a prompt, so which forms the root of the conversation tree. So it's basically about deciding the topics for which you will create the trees. That was the easiest task in some ways. Right? The second task is replying as an assistant, and this is a little complex task because here the human has to sit down, the worker has to sit down and provide a helpful and relevant answer to the prompter's request. The third task is replying as a prompter. It may, so basically the idea is that the person who is replying has to essentially look at the prompt, look at the entire conversation so far, and based on that, based on that reply as a prompter. Now, this reply could include asking for clarification, modifying the original intent, or posing a follow-up question, changing the direction of conversation. Totally, all of these are possibilities. The fourth task basically involves several subtasks. It's basically labeling a prompt or a reply given preceding conversation thread. So in this particular task, the human worker is given the preceding conversation so far, if any, right? And then there's a prompt or a reply, and the person has to essentially grade how good is the prompt or the reply, right? So in fact, the grading was done along three main kind of perspectives. So spam detection, guideline adherence, and quality, right? So as part of spam, of course, you don't want threads, spammy threads to be a part of the data set. So therefore, all kinds of such spammy things were deleted. Guideline adherence, so any kinds of bias and all those kinds of other spamish things, but not completely spam, were also deleted. So so the idea here for the labeler was to check if the reply adheres to the guidelines which was specified. Guidelines of being diverse, guidelines of being respectful, guidelines of being non-biased, and so on. Okay, and quality. So in fact, the quality was measured along these various characteristics on a 5-point Likert scale. So creativity, in general, quality, humor, helpfulness of the answer or reply, violence, or rudeness. Right. So all of those criteria were used for, and they are a part of the metadata which is applied along with the conversations in the dataset. Workers were also asked to label provide binary labels based on these things: language mismatch, not appropriate, personally identifiable information, hate speech, sexual content, and so on. Right. Lastly, people were asked to rank assistant replies. So of course, for a single assistant, you have like multiple responses here, and for a single prompter response, you have multiple responses here. So how can you rank them? Which one do you consider is better? And this ranking is very important for learning the reward model, right? So they were asked to rank, and then ranking was not obtained, just by a single person. It was actually obtained by asking for the same preference pair to be for the same pair of responses to be ranked by multiple people, k different people. And thus, for the same responses A and B, you would have k different preferences. Now, so then how do you merge? So basically, if you had like several, so let's say L different responses, or rather, if you have several such responses, how do you merge them? So how do you sort of figure out, which ones are rated higher, which ones are rated low? I mean, how do you finally come up with the overall global ranking, right? So essentially, if you have L different responses, you would basically have LC2 different preference votes. So in the sense that for LC2 pairs, essentially you have some votes, right? So some votes favoring A over B, some votes favoring B over A, and so on. Okay. Now for each of them, the idea is to basically, let's say if the highest vote was provided to B is better than C, B is better than C, you would create an edge in a graph B to C, right? And so on. So you would basically create a graph of this kind such that you take that particular preference pair where the vote is the maximum, right? And then you build an edge in the graph. Now, and you keep building more and more edges in the graph by taking those pairs with highest votes until you do not create a cycle, right? Until you do not create a cycle. If you create a cycle, you basically ignore that particular edge and don't put it into the graph. Okay. This is also called as the ranked pairs or the Tiedemann's method, and that is what was used to finally come up with a global ranking for assistant replies. Okay. So this is how the data was collected. Overall, more than 625,000 tasks were done, and then more than 2,000 fully annotated and filtered conversation trees have been created. Now, of course, here I've mentioned that there are 66,000 conversation trees in the dataset. However, out of this, around 52,000 conversation trees actually consist of only a single initial user prompt, and it has had not even a single reply so far, right? So that's that. So basically about 11,000 of these are complete trees, meaning the full number of messages have been collected and the moderation process for these trees has been concluded. So everything is good for those 10,000, 11,000 context trees, the conversation trees. Right? Most of this data is English and Spanish, as can be seen from this language distribution. Some of it is Russian, German, French, but then mostly it is basically English and Spanish. Okay. So how did they use this data to train OpenAssistant models? Well, they instruction-tuned Pythia and Llama models, Pythia 12 billion and Llama 13 billion and 30 billion models. The reward models are also released as part of the release. So of course, they have released the instruction tuned models publicly and also the reward models. They trained using supervised fine tuning. They actually trained reward models, and they also PPO fine tuned the reward PPO fine tuned the supervised fine tuned models using the reward model predictions. Okay. So samples for supervised fine tuning look like this. You would basically take a conversation tree, take threads from that conversation tree, and each thread was used as a sample. So the way you would create a sample out of each thread is to start with a prompter token, and then you would have assistant tokens, and then prompter tokens, assistant tokens, and so on, right? So the entire thread with the special tokens in between, as you can see here. Right? Of course, each of those prompt or responses can have multiple tokens themselves. As part of supervised fine-tuning, it was fine-tuned using the regular language modeling kind of thing with a small tweak that you must tokens that correspond to prompts and only train to predict tokens that correspond to assistant replies. So you compute loss with respect to assistant replies. Reward model. So for reward model training, you replace the language model head with a linear layer, which basically computes the reward score. So we will call that reward score as R theta, where theta are the parameters of the reward model. And R theta sort of corresponds to the prediction score for the last reply of the conversation. So how good is that last reply? Is the intuition, or is the thing which corresponds to the predicted score, right? So you use k replies to the same prompt and get their rankings. So you essentially have, let's say, k replies to the same prompt in your data set. So you basically produce KC2 comparisons and train to minimize this loss, right? So if you have k replies, you have KC2 comparisons because human annotated comparisons are available. So you know which response is better than which other response and so on. And what you want to do is to maximize is to minimize this loss where where YW is actually preferred over YL. YW is preferred over YL, and you have a negative sign outside, right? So essentially, the idea is that you want to define a reward loss function such that it predicts a higher reward score for responses that are preferred, right? So once this reward model is trained, once the supervised fine-tuned model is there, you want to do PPO training. So PPO training is a reinforcement learning method. So you produce assistant replies to unanswered questions. You take unanswered questions, ask the model, hey, give me replies. When the responses are generated, you ask the reward model to score those responses. Use the reward model to score those replies, and then you take those scores, those rewards, and then you use them for PPO training. So specifically, they use the TRLX framework, which is very popular for this PPO training. So as to basically avoid the model from drifting too much, in some ways to regularize the model, they also add a per token KL divergence, scale penalty from the SFT model to avoid instability and over optimization to the reward model. They didn't want catastrophic forgetting of the supervised fine-tuning model to happen, and therefore they also involve this per token KL penalty loss. Okay, so in summary, in this video, I talked about OpenAssistant, which is both a conversational data set and a bunch of models fine-tuned using this conversational data set. In the beginning, they fine-tuned Pythia 12 billion and Llama 13 billion and 30 billion models. The dataset contains 161,000 messages, 66.5 thousand conversation trees, 35 languages, and it is annotated with 461,000 quality ratings. However, around 11,000 of those conversation trees are really meaningful because they actually contain conversation threads. In the instruction tuned Pythia 12 billion, Llama 13 billion, Llama 30 billion models, and they found using a user study that answers generated by Pythia 12 billion are 93.5% as preferable as those produced by the GPT 3.5 turbo model. So that's that. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.